Prepare yourself for an incredible voyage into the mysteries of Jupiter, the largest planet in the solar system. Although you may believe you already know everything there is to know about this giant planet, the fifth example in this movie will blow you away with its amazing auroras and enigmatic Great Red Spot. Astronomers have been captivated by Jupiter for ages, music. However, have you ever wondered what lies beneath Jupiter's swirling clouds? In this video, we'll examine the most recent NASA discoveries and unveil the amazing wonders of Jupiter's core atmosphere, among other things. So, buckle up and get ready for an exciting journey. And don't forget to like this video, subscribe to our channel, and leave a comment below with your favorite Jupiterian fact. Let's dive in. Music. NASA discovers unexpected depths in the Great Red Spot on Jupiter. In contrast to Earth storms, which usually last a few days or weeks, NASA's Juno spacecraft allows us to finally see the largest storm in the solar system as we explore the depths of Jupiter's Great Red Spot. The Great Red Spot, which resembles a supersized storm made mostly of clouds, has been continuously seen by scientists for around 200 years, though it is thought to be much older. Despite being seen from a distance for centuries, the Great Red Spot has shrunk and changed its shape, making it more mysterious. In 2011, NASA's Juno mission set out to visit Jupiter. According to planetary scientist Paul Byron, it is comparable to cyclones, hurricanes, or typhoons on Earth, but with a diameter of 10,000 miles, it is much larger than any storm on our planet. After arriving on the planet in 2016, the spacecraft altered course in 2019 and passed over the Great Red Spot twice, enabling NASA to produce the first three-dimensional, 3D model of the enormous vortex using microwave sensors. During its Jupiter expedition, NASA discovered something surprising. The Great Red Spot storm is more than 200 miles deep in Jupiter's atmosphere, deeper than the normal depth at which clouds form and water condenses. Microwave observations also reveal that Jupiter's vortices, like the Great Red Spot, extend deeper than the planet's cloud deck. These revelations could lead to new models and ideas to explain Jupiter's atmospheric processes. However, even though the Juno spacecraft passed over the Great Red Spot at 130,000 miles per hour during its 2019 mission, the massive storm caused it to experience bumps due to the vortex's gravity field. This discovery is very different from how Earth's atmosphere functions and presents a new challenge for scientists to comprehend. By using radio waves to measure changes in the spacecraft's distance from Earth, scientists are able to monitor these gravitational disturbances. According to Juno scientist Marzia Parisi, the observation showed that the Great Red Spot's gravitational field stretches 300 miles into Jupiter's atmosphere. The exact measurements needed to gather this data were astounding. The gravity measurements outcomes support Scott Bolton and his team's earlier conclusions from their microwave observations. The Great Red Spot is getting smaller. NASA's Juno spacecraft is currently studying the storm's behavior up close. The spacecraft has seen flecks of the storm being captured by nearby clouds, and the storm itself appears to be confined by strong wind conveyor belts on the planet that are stabilizing it. However, scientists have not yet linked these observations to the changes in the storm size. Jupiter's iconic storm has been diminishing for nearly 150 years, and it is unclear how long it will last. Researchers will use Juno's data to better understand the storm's dynamics and create more intricate models to forecast future events, such as when the storm might dissipate. As seen by the 2019 storm's fragments flaking off, Jupiter's Great Red Spot is erratic and its winds are growing, raising fears that it may disintegrate. Researchers examined Hubble telescope data from 2009 to 2020 and found that, although the winds around the storm center moved much more slowly, the winds in the storm's outermost lane or high-speed ring increased by 8%. This unexpected increase in wind speed was not explained by the conversion of angular momentum. Scientists can only examine the changes over a comparatively lengthy period of time, and they are small. the need for greater vision under the cloud tops limits our existing understanding of how storms work. Why is the Great Red Spot on Jupiter? While there are some fascinating explanations for the Great Red Spot's distinctive hue, they are contradictory. Some scientists think the red color is caused by chemicals that are located deep beneath the storm's cloud tops, while others think that photochemical products like smog may be a contributing factor because the spot is covered in clouds or extremely dense haze. However, Simon and Wang's team have found similarities between the storm and mid-Atlantic eddies that could help guide future research. Others claim that it's because sunlight breaks up different chemicals in the storm's upper atmosphere. If the latter is true, then the rest of the Great Red Spot is not red, and we only see the sunburn at the top. At this point, it's impossible to predict what will happen next to the Great Red Spot because it's a unique phenomenon in the solar system, with nothing like it to compare to. Simon believes that Jupiter has a number of stable storms, but none are as large as the Great Red Spot. Therefore, if it were to vanish, would another storm like it form? Jupiter is known for being unpredictable, and storms are no different. Jupiter's chaotic beauty is produced randomly yet consistently by its distinct chemistry, and the Great Red Spot's demise could signal the start of something else. The Great Red Spot's future is unclear. Only time will tell what transpires. The moons of Jupiter and the information they provide. With between 80 and 95 moons, Jupiter's intricate system of moons, rings, and asteroids is made up of thousands of tiny objects that orbit the massive planet. Nevertheless, these figures do not adequately capture the intricacy of the system. Small moons would only be given mythical names if they were of significant scientific significance, according to the International Astronomical Union. The four largest moons of Jupiter were initially observed by Italian scientist Galileo Galilei. Galilean satellites in 1610. Io, the solar system's most volcanically active satellite. Europa, which is believed to have a salty ocean and could be a great place to search for extraterrestrial life. Ganymede, the solar system's largest moon, which has a magnetic field. And Callisto, the solar system's most heavily cratered object. Larger moons may have been grabbed by asteroids, but Jupiter's four faint rings are made of dust from its four innermost moons. Smaller ones might be parts of bigger ones that clash with Juno's composition and vibe. Although Juno is the largest planet in our solar system, its atmosphere is composed primarily of hydrogen and helium, with layers extending downward. Its atmosphere is 90 hydrogen and 10 helium, and its pull of gravity is 2.5 times stronger than Earth's. Scientists believe that Jupiter's central core is surrounded by a dense layer of metallic hydrogen and another layer of molecular hydrogen. The exact composition of the core is unknown, but it is believed to be either a hot molten ball of liquid or a solid rock that is 14 to 18 times the mass of Earth. Despite Jupiter's lack of the mass necessary to initiate fusion and turn into a star, Jupiter is still 2.5 times larger than all the planets in our solar system combined. The potential presence of water on the moons of Jupiter. The Jupiter spacecraft also captured clear images of the moon to support the research. NASA issues. Galileo Orbiter recently found that Europa, one of Jupiter's moons, may have water reservoirs within its icy shell. These reservoirs are near the surface, some just a few kilometers below, and may erupt above the surface as plumes of vapor or cryovolcanic activity. The finding clarifies how plumes may influence water depth and surface activity. These shallow, liquid reservoirs will be found by NASA's future Europa Clipper mission, which may also investigate the outer solar system's most accessible liquid water bodies. Researchers are still examining the composition and characteristics of the subsoil, Europa's lakes, Jupiter's magnetic field, and its effects on the planet. Scientists think that electrical currents in Jupiter's magnetic hydrogen interior are the source of its powerful and intricate magnetic field, which causes it to rotate more quickly than Earth. At the summits of Jupiter's clouds, the magnetic field is 10 times stronger. In addition to having special characteristics not found on Earth, Jupiter's magnetic field is more complex than Earth's. It is toroidal and has enormous Van Allen belts that trap highly charged particles because of Jupiter's rapid spin. These belts are flattened into plasma sheets. Every 9 hours, Jupiter's magnetic field spins. As it passes through this region, objects like Amalthea, Europa, and Ganymede are impacted, and the magnetic field's particles may harm Io's surface while it orbits Jupiter. Auroras and the magnetosphere of Jupiter has a powerful magnetic field that interacts with charged particles from the Sun to create a bow shock that deflects them. The strength of the solar wind affects the magnetosphere's size and form. In order to explore the possibility of a giant ring system surrounding Jupiter, astrophysicist Stephen Kane of the University of California, Riverside, and his colleague, astrophysicist Ji-Xing Li, conducted a series of simulations of Jupiter's objects. The simulations, which took into account the orbital motion of Jupiter and its 4 largest moons, revealed that Jupiter could not have Saturn-like rings because the Moon quickly destroys any large rings that may form. Jupiter forms massive moons as an enormous planet, preventing substantial rings from forming, unlike Saturn's ice-based rings. Other planets and objects such as Uranus, Neptune, Terraclo, Haumea, and Mars may also have or form rings as a result of gravitational interactions, although Jupiter's thin rings are primarily made up of dust ejected by some of its moons. Rings, formed by removing ice from a planet's surface, can reveal information about its past. Can people survive on Jupiter given its severe temperatures, pressures, and materials? 3. Like blood splatter on a crime scene's walls, we have now explored the mysteries of the giant planet in the solar system. Jupiter is not suitable for supporting life, but some of its moons, such as Europa, may. Evidence indicates that Europa has a large ocean beneath its icy crust that could provide a habitable environment. Thank you for visiting us, and please, remember to like this video and leave a comment below till the next time. Jupiter continues to captivate us with its secrets, including an explosive atmosphere and a mystery core. Who knows what scientists will uncover in the years to come? Continue discovering the universe's wonders.